First of all, once you've built assembled, so we are going to disassemble it. By removing the eBay. In doing this, I'm also going to show you some tricks to ensure the cardboard's a little bit stronger. Okay, so I hope everybody can see me. So off with the payload section, remove it from the booster section, and to keep your alignment about where your holes is, remember we did the marks. So when you look now, you can see your holes aligning. So just put this aside. We are now going to focus on the forward bulkhead. The screw eye for the recovery harness retention. The connector block for connecting your wires to your ejection charge. And you can see me screwing in the screw eye through the hole in the connector block. So with that hole that we drilled in during the assembly video, make sure that it is level so it doesn't interfere with the assembly of the body tube. Now we are going to drill another hole. This one is where the ejection charge wires that connect to the e-bay is connected. Will help. I've got this tool to help me make it easier for me to drill the holes and let the drill bit not run around. Hopefully. Okay, it's one of those days where you use a thin bit and then go over to a thick bit. I'm not perfect at this, it's just okay, small hole or a pilot hole, and then you go for the thicker one. Okay, that's thick enough for the wires to pass through. So now you'll need 2 sets of wires that has been stripped to a point. Feed the wire through. Strip it. So we move on to the connector block, sometimes called the chock block. One side is where we will connect it to the avionics. The orientation is not important since this is a simple circuit that will go from A to common. I will go into detail with that in a bit. Ensure it is tight. Now we can pull this back a little bit. And we're going to seal this with hot melt glue because we don't want any of the ejection charge residue to go into the E-bay. It is corrosive and it will damage your avionics. So hot melt glue is a wonderful tool both for gluing stuff down and for making things airtight. So there we go. That is done, and this is ready to be connected to the avionics. Next we get to the avionics. This is S.T.E.M USB version 4, and on this side is where you connect your switch and your battery and this side is where you connect your ejection charges, because this is the events section with an A, common, and B. B is your secondary event. A is your default apogee event. It's got a micro USB socket. It allows you to connect it to the computer, and with the software you get from Intercore, you can download the data on the S.T.E.M USB, and it will give you a graph about your speed, altitude, so you can see how your rocket performed. It is very dependable. I've been using the S.T.E.M USB for a very long time now, and I have not been disappointed. Of course, if they're in a crash, they don't. Sometimes they survive, sometimes they don't. It's one of the risks you take. One of the risks is flying when it's very, very windy. Okay, so we are going to connect the battery clip to it, and the red is the positive. Add me to Fortnite Oliver Bros. Who the heck? But in any case, if you have the equipment, putting a ferrule, however you pronounce it, will ensure a longer lasting connector. So we connect the red for the positive value to the first one here. Make sure it is tight, because if you let go and it falls out, then you know it didn't work. Oh, that's why. Okay, I folded it over so there's more surface area. The things about doing live streams, it's not always perfect. Okay, now it's in tight. But now we're going to connect this with the second wire. This is going to be the common, and to connect the neutral with the positive, since this will continue the loop, and this joint goes into the middle. But I skipped a step. To get this wired through the hole here is going to be a little, through this for the key switch or the on-off switch, going to be a little difficult. So we do that first. Yeah. Live streams are never perfect. Okay. So we pull that through. And we'll just keep this cable in place with some masking tape for now, so we don't accidentally pull it through all the way. Technically speaking, connecting this up any which way won't make a difference, because it's just completing a circuit. So we go back here. The important bit is making sure that this goes into the common. Sorry, it's very, very small. And this now goes to the negative outlet. The thing you must ensure is that the wires cannot touch the open places. Otherwise you'll get a short and then it won't work very well. So okay. Now for the bulkhead with the ejection charge wiring. As I said, this now connects to A and common. A and common. Common is the one in the middle. We've once had people connecting A to B and then wondered why the rocket didn't deploy the ejection charge and crashed, because B follows A, because ABC, but we work ACB. Because C isn't after A and B, it is common. Because the S.T.E.M used B for first event sends power through here, and then for B event sends power through here. It is a very intelligent recording avionics. And basically, your avionics is now done. So to test it, almost done. Now, this is the switch I chose. One of the advantages is it's got little holes through the pins, which means you can just push your wire through the holes and get a good connection. I'm not going to solder these because, well, my soldering sucks. So, what you've got to ensure is, because it's got 3 pins, is that you know which side is on and which side is off. So if it's down, it means common and this one is connected. If it's up, then those two are connected. So what we're going to do is prep the wires, and then we are going to mark out the size of the switch across the hole. So you get a pen. This switch is very, very small, so it won't be a drastic operation. And we mark off the edges. And the width is the size of the hole. So I go in and I mark the amount that we have to cut out. So we take a box cutter and very carefully we are going to cut out the little box where the switch is going to go in. Don't worry about any excess cardboard. It will just help to make the switch grip more firmly inside the E-bar. Always blades away. So now, just going to split the wires a little. Find our mini switch. We want the switch to be on in the down position, so that when it takes off, there isn't the possibility of the G-forces pulling the switch down and causing it to switch off the altimeter. That would not be good. So sorry, this is now needlework. I'm going to use some insulation tape on this a little later, just to make sure the wires don't touch. Because, well, it's only a few millimeters apart. Okay, so now I've got them separated. Just going to take some masking tape for now. And because they're just taped on, if you need to do any alterations, can be done without too much issues. So now we're just going to connect the battery. Since it's in the on position, and off. When you switch it on, you must listen for the following. 3 fast beeps, 3 fast beeps means sufficient battery and sufficient memory for a flight. The next will be continuity on A and continuity on B. Because there's nothing connected, it should give us 3 long beeps and then 3 long beeps followed by continuous beeps showing it is ready. So flick it down. Everything's perfect, and switch it off. So during flight, because this is a slide switch, you can put a piece of tape over the switch to keep it from accidentally going off after it lands, because sometimes it falls on that switch and the altimeter beeps out the altitude for you without having to be connected to a PC. But in case the switch does go off, you can download the information. So I'm just going to leave it like this. Then altimeter goes to one side, battery goes to the other side. People ask, why don't you put it on a board? It's not that important. I've been doing this for years. But you can make what's known as a sled that slips over the center threaded rod. Let me just turn up the connector block. There we go. Now the washer is all the way down. We can add the nut. As I said in a previous video, cutting this down is a good idea. The reason the threaded rod is so long is because for the dual deployment eBays, we have longer eBay, and this is cut for the longer eBay because we have ejection charge this side and another one on this side. So dual event, and that means the B ejection charge or event has a wire that goes down to the bottom, goes out and has another connector block that's on this side, and to connect the second ejection charge on this side with your rocket booster and payload section, well, it's got two payload sections, one for the drogue in the middle, one for the main in the front, and the booster at the back. So here is your eBay. Now to keep this nice and tight, you just take a little bit of hot melt glue, and yeah, this is now just a quick, it's designed so I can remove it later in case the connection comes loose or such. You just remove the hot melt glue and you can pull it out and you can fix the wires. So the whole thing about this design is fixability, self-repair. So if something goes wrong, it's very simple. It's a simple pathway to follow. And there we go. Okay, so this has been your eBay assembly. I hope you found it helpful. Have a good day. And